Hello guys, my name is Diego Pacheco and today we're gonna have a slide cast. Today I will be talking about CDKs, which means Cloud Development Kits. So CDKs are getting more popular nowadays. We have CDK from AWS, we have CDK from Terraform, there is also other CDK alternatives out there, like Polumi is a very interesting one. And I want to talk more about all what's going on with you guys, right? So I'm gonna have the slide cast, and besides the slide cast, I'm gonna be a short one, but I want to discuss some points, some topics. And after the slide cast, I have two code POCs I made, one with Pulumi and Python, and the other one with Terraform, CDK, and Java. And I want to show the code to you guys as well. So let's go to the slide cast. So CDKs, Terraform is one of the best, in my personal opinion, is the best infrastructure provisioning tool out there. Is not the first by any means. There are several other solutions like Puppet, Chef, SouthStack, Ansible, CloudFormation from AWS, and also Terraform. Terraform is declarative. So here on the right, you can see some other POC I did with Terraform. Here's the link to my GitHub if you want to get the whole source code. But here I'm creating a KMS key and S3 bucket, and I'm moving a file to a bucket. And all that happens with this declarative fashion we can see in Terraform, where I'm not saying specifically which APIs Terraform need to call in AWS under the hood, and I say more or less like the data want, the properties that I want. In that sense, it's like a DSL, like a SQL or Bash, and that gets translated into AWS SDK or API calls in the end of the day. Terraform is cool and great, but Terraform is pretty much like a op-ish solution. If you think about DevOps, the whole movement started more towards ops. So these tools, like if we look like old tools, like provisioning, like for instance, like SouthStack or Puppet and Chef. Puppet and Chef was built on Ruby, pretty popular language on infrastructure. Ansible was built on Python, even more popular language for infrastructure. And Terraform was built on Go. I cannot say that Go is a popular DevOps tool, but there is like this movement of ops solutions built in Go. And Terraform is one, etcd is another one, Kubernetes is another solution written in Go. But what I want to say is that Terraform was mainly designed to be used by ops professionals, and nowadays, even when we say DevOps, several folks just think ops, right? And it's very common to have a DevOps team, but besides that, DevOps is a movement. It's about changing culture and changing the way that we build and operate software. So in that sense, Terraform really was more tackling like the ops space. But in my point of view, Terraform is really great. It's declarative, and it has the best thing ever, which is the state management. That's really the hard part, figuring out the deltas, because Terraform does not just blindly call AWS or cloud or whatever provider API. It does state management, and then it knows exactly to do the deltas and only apply the differences, when to create something, when to destroy. And that state management is really priceless. That's really the cool thing about it. However, nowadays it's very common that we see solutions that are sort of a no ops or no backend. More and more we see like mobile engineers just accessing cloud resources directly, and that's sort of a big trend, as we also get front ends more structure, like we see movements like micro front ends, for instance, and it's also common now to see more and more front end and engineers, and especially front end engineers or mobile or JavaScript having to deal with the cloud. And if we think about startup or even about being native, and what I mean by being native is often companies they are labeled by being like a Java shop or a .NET shop or a Go shop, etc. There are companies that are flexible and allow you to work with multiple languages, but often companies they have like the main language that they work. That's pretty common, like Java shops or .NET shops, for instance. Um, and engineers, and it's very common to see this on the industry, that you would like to be native. Like if you have a Python shop, you want to do all the things with Python. If you have a Rust shop, you want to do all the things with Rust. And that's like the movement that's happening with provisioning right now. So you might want to do things with TypeScript or Python or even Java if you are a Java shop. And engineers fundamentally they are different than ops professionals. If we see how Google implemented SRE was sort of a different front than the DevOps movement. If we look to the founders of the DevOps movement, we see some were dev background, but the majority is ops background. And what we see on SRE, what happens to Google, is sort of the opposite route, where you get engineers that are pretty good on engineering and algorithms, and you teach ops to these folks, and that's what happens. You get more automation. But besides this SRE front, this is like a different front, a different movement that's going on, where more and more, back-end and front-end engineers are exposed to the cloud. And with that, there are popping up these CDK solutions where this is more towards for the developer experience rather than the operational experience. So the language they change, and you sort of have a DSL, but this is more like a DSL into a mainstream or a niche or target programming language for engineers, not for operational folks. So with the CDKs, mainly these three players right now, which is we have the AWS CDK, which mainly translate things into CloudFormation. We have Terraform CDK, which translate things into Terraform, and we have Pulumi. I don't know exactly what happens under the hood, but it's an interesting solution. So the CDKs are heavily based on the idea of a code generation, because like I said before, the state management is the most important part here, and we don't want to lose that. And if you plainly just see this and just look into the engineering or into the programming point of view, which if you just code something in any language like Java or Rust or Go, you might have a problem if you're just calling an API, right? The first time you call gonna work, but what's gonna happen is when you call the second time. So, and you don't want to embed state management everywhere every time you want to do provision, and when you want to create elastic load balancers or VPCs or security groups or RDS clusters. You want to get that for free, you want abstraction for that. So that's why you need to have something that does the state management. And in this case, CloudFormation or Terraform will do that for you. And the CDK is basically going to be like a bridge or an API that's going to be better or native for the user, which in this case is going to be an engineer, not an ops professional or DevOps professional. And the side effect of that, you're going to have some code generation. I personally think if you use it very well, code generation can be very powerful. However, what we see on the industry often is a horror show. Often we see code generation as something really bad, that really sucks, is low. And we also have some concerns with the CDKs. I'm going to show you some evidence in a moment. But that's something like more like a trade-off. Like everything in life, you have trade-offs, right? So some pros and cons, and with CDKs is the same. As you get something more native to engineers, you also have this side effect of or con as code generation. Okay, talking is very cheap. Show me the code. I will show the code, but before I show the code, I actually want to open some websites and then we go to the code. But that's the slide, guys. Okay, So here in my browser, let me show some stuff to you guys. So let's start here. So here we have the CDK patterns from AWS. I think they launched this on a reInvent in 2019. I got the chance to be there in person before the pandemic and everything. Good old times. But like here you have lots of examples like to provisioning lambdas, event bridge, Dynamo, Alexa skills, S3, S3 serving like a website, WAF, X-ray, etc. So let's see like this Angular website here. And then we can see that we have Python and TypeScript. Mostly you're gonna see Python TypeScript here. Sometimes you might see Java, but mostly you don't. So here we can see Java on this state machine, but mostly it's Python and TypeScript. I would say even TypeScript looks like being the main target language. So if I go here, all right, and we go to, let me see here. So here we even have some diagrams, which is the cool part, what's going on. Then we can see the package.json, right? And we can see some build spec here. And here I believe is the solution, like the site they want to serve. And here we have the CDK part. And we have the CDK configs. We have the template.yaml. Here we have roles and buckets and several configurations for AWS, right? You can take a look here. It's quite interesting. I personally don't like this. Not that I don't like CDK. I like this particular CDK. What I don't like is what's under the hood, which is CloudFormation. In my point of view, CloudFormation is very complicated comparison of Terraform, and I personally don't like it. But I will provide these links on the blog post anyway. So there is this other guy called Pulumi. I would say not like a usual name. And this looks like an agnostic CDK. And there is a sort of platform around it as well. Some nice UIs and consoles, and you can see what's going on. I did some POC as well with this guy. I'm gonna show you, but mainly you can see there's support for cloud providers and Kubernetes. Most of CDKs I'm seeing nowadays, they are also tackling the same landscape, cloud providers and Kubernetes. And finally, we have the Terraform CDK. So here you can see it's like you can either have some CRDs on Kubernetes, HCL, which is HashiCorp configuration language, I think, or JSON, or CDK, mainly on TypeScript, Python, Java, C#, and Go. You can see TypeScript being the first option as well. And then use Terraform to do the state management and providers, right? Mainly cloud or Kubernetes. There is a CLI in Node.js you need to install. This is a kind of a big, takes some time to install it. Here you can see the supports per language for each CDK, like TypeScript, what you can do with TypeScript, Python, Java. I did my POC with Java for this one, so we can compare with the TypeScript. And here we also have some examples. You can, if I go here, examples, you can take a look per language. Okay? Now, let's go to my POCs. First, let's start with Pulumi. So I'm gonna open my VS Code here. Pulumi is quite simple. I did this with Python. So in my requirements.txt, these are the libraries. So you wanna do pip install -r, and then you want to point to this requirements.txt. And in my case, I want to do Kubernetes thing, so you need to have a Kubernetes cluster up and running. I have a Minikube, that's how I roll here. and we need two dependencies. We need Pulumi and Pulumi Kubernetes, right? So we're always gonna have Pulumi and the provider you might need. Then you have two files. I have Pulumi and puluvdev YAML. So in Pulumi dev YAML, which is my environment, I have a config saying Pulumi Kubernetes Python is minikube true. So I can tell if I'm running against like a EKS or whatever Kubernetes cluster manager you're using, like Rancher or whatever, or if you're running against Minikube. In my case, I'm running local on Minikube, so that's why you're seeing this. And then on Pulumi YAML, you have the name of your application, you have the CDK runtime you're doing, and some description, right? Then here is the code, right? So let me get this to you guys. So here's Python. I need to import Pulumi, and I am doing a deployment in a service in Kubernetes. So this is the Pulumi API, and this is all Python code. So I'm doing some imports here. Here there's some comments. Then I create a config. I'm also reading from the config asking, is this minikube? And then defining that app name is ngx. And here's like the JSON for that app, like a dictionary. Defining the deployment. And then putting my app name, saying the spec, and define the selectors. I just want one replica, some labels, and also the container name of that solution, which is going to be nginx, the Docker image that's going to run there, nginx as well. Then here we define some front end, and then this is all like standard Kubernetes, but as you can see, we can do in code. Python is interesting in that sense because your code gets very fluid, and you can do some replacements here. So this is actually cool. And then there's a if here, depending, because if you're running on Minikube, you get the cluster IP. If you are in a real cluster, you need to use a load balancer to go through first, because the IP is not directly exposed to the cloud. And you do export, and basically you run Pulumi, and he will create the resources for using this code. So this is cool if you are like a Python engineer, or you're working on a Python shop, or you're more like ops. This might serve both dev and ops pretty well. And it really depends what kind of a problem are you fixing, because I would argue that there is a difference between standard microservices and like some infrastructure work that you are provisioning. And when I mean infrastructure, let's say your team does some infrastructure as a service. For instance, in my case, in the past, I built Cassandra orchestrator, and then I built automation to deploy that orchestrator. That solution had multiple languages like C, Java, Python, and then it had to install itself in multiple pieces of software, and also create specific resources on AWS, like EC2 instances, autoscaling groups, security groups, and I provide that as a generic solution with a Jenkins jobs where you could go there and self-serve create a cluster for you. So all that provisioning was not like a standard provisioning, end up using a lot of Python and Java to create the solutions on AWS. And that's interesting because back on that time, this was around from 2015 to 2018, there was no idea of these CDKs, and I didn't have any state management. I had to handle things from myself. Now, if I have to do the same with CDKs, it would be much easier. But that's a very specific use case. Not all the time, you have a platform team, or you are working in this sort of infrastructure work that your customers are internal engineers rather than the product organization. If that's the case, you are a platform team or a DevOps team, and depending what you are building, a CDK might be a very good fit. But for overall provisioning in self-servicing, I don't think that's the right fit. And even I would argue that's more complex and even more code, because Terraform is pretty compact and very easy to reuse. But again, there's some sort of a preference here as well. Okay, but that's my POC with Pulumi. And now we saw Pulumi. We're gonna continue in Kubernetes, but now we're gonna see the Terraform CDK in Java. So let me open my idea here. Okay, so we have a bunch of things here. So let's start with my pom.xml because it's a Java application. So in sense of dependencies, I have dependencies for the HashiCorp CDK, so CDKTF, CDK Terraform, and I have this software constructs, which is some of the dependencies of the provider that we're gonna use. That in this case is gonna be Kubernetes. So these are the dependencies. Also, there is the Zach plugin configured to run a Java main class. So if we look here, there's some files, right? So there's a cdktf.json where we define what CDK we are using, in this case, Java. What we need to do on the app, so we need to run mvm -z-q compile and exec Java. And what providers, Terraform providers we are using? We are using Kubernetes, and here is the version. Let's go to the code, and I can show some more stuff later on. So on the code, this is when you run some code, some objects going to be generated here. So let me open the README, it'll be easier for you guys to understand. So what you gonna, let me see, can I get this bigger? I don't think you can get this much bigger. But first thing you need to do is a npm install -g cdktf -cli. So we're gonna have Terraform CDK CLI installed with this line. And then you need to have that cdktf.json. And then the first command you want to do is cdktf get and cdktf synth. And this will generate some stuff for us here. That's the part where I have mixed feelings. I don't like much. If we go on resources, we're going to see there's this model.txt that points to a bunch of classes. And there is a tjzip file with a bunch of things inside. And in my Java, there's this imports.kubernetes that was generated here. And if you look how many classes was generated here. A lot, right? Yeah, a lot of things. So if you click here, you can see the code. It's kind of a verbose. I don't know why they're generating here, why they don't put this on a lib and that's it. But anyways, how it works, I found this a bit weird because you have a lib and you also generate code. And well, here is Java. Not to blame Java, but I believe this DSL could be simple, right? I think that's we can do a bit better even being Java, but anyway. But here, similar example, right? So again, Kubernetes. So you need to extend a Terraform stack. Then here you define the provider, which is Kubernetes. And then we're going to create a namespace called tfcdk example. And here we're building that. And here we are doing, like in my Pulumi code, where I'm doing an ngx deployment. And I'm defining the name of the deployment. And here, if you go down, there is the deployment spec. So I'm saying that it's 2 replicas. In Pulumi 1, I did 1 replica. Then putting some selectors, putting the Docker image we want, and defining some things like CPU, memory, and building that. Okay. And here we have a service, Kubernetes service. So we create an nginx service for that deployment, putting some selector, defining node port and port, and building that. And here on the main, we create the app and we do synth. As you can see here, this is 100 lines. Of course, if I do it in TypeScript, it will be smaller, but then TypeScript is sort of a compiled, so it's better, right? But it's not like a language like Java, but it's compiled. It's not like JavaScript. But as you can see, this is quite big, right? I think we definitely they can improve the DSL, but this is quite big. Again, it really depends on your use case. I would say regular use cases, that's not a good idea. Would prefer to go Terraform, much more simple for microservices deployment. But if you're shipping an infrastructure solution, you work in a DevOps or platform team, CDKs might be interesting for you. Also, there's some files that are generating. Let me explore here. So you're gonna see this CDKTF out, where you're gonna see some JSON, which pretty much has all the instructions for Terraform. So you're gonna see the specs, the Kubernetes specs here. You see container port, the resources limits we have there. And I run this, and as you can see here, I have a TF state, and it works. But like I said, I think the code generation here is a bit weird. I personally don't like it much. But CDKs are growing up nowadays. I think they're getting more and more popular. So I hope you guys like this slidecast and code walkthrough. See you next time. Take care. Cheers.